What? I don't understand Apple speak. What are you talking about?
No,
What?
sound effects.
Yeah, sound effects are clearer. Yeah. What is first? What is the first question?
Version 2.
Now you see, he's ready though. He knows the number and everything. Do you have your question ready? Oh. I flipped for who goes first. Your heads, your tails. Heads, you're going first.
Okay.
Right, what's the first question? So, what page? We'll write it
Page
down.
number 5.
Page 5.
Version 2, question number 80.
Version 2, question
Number 80.
2. Yeah. Okay, so what is the question? Can I have a look actually? It'd be easier, I think. A stone of mass 4.65 moves at a speed of 3.26 on horizontal icy surface, collides with a second stone of 2.41, which moves off in the same direction at a speed of 4.12. Guys, are you all looking at this one? Boom! It's right there. Page 5, version 2, question, yeah, that's right, I did. A mass of 2.65 is attached to one end of a 1.34 length of string. The other end is fixed to a rigid support. The string is fully stretched out in a horizontal direction and the mass is then released so that it falls in a circular arc. Determine the tension in the string when the mass is at the lowest point. Right. Really, really complicated question, but really, well, not really simple, but it's what they have is they have a string here, and this is 1.34 meters, and this is 2.65 kilograms.
Is it pendulum question?
Well, not quite. Aha, they're very sneaky. So it starts off like this at the beginning, and then it swings a quarter of the way down, and they want the tension when it's at the lowest point.
Lowest point. Really?
It says that in the question, doesn't it?
Yeah.
Find the tension in the string when the mass is at its lowest point, lowest position. Okay. This is recording. Yeah. Okay, let's have a look at this now. This one is tricky, but I think what we could do is let's have a look at the tension part first and then think about what we need. So this here is T and this here is mg. And which is bigger, T or mg?
Just the same.
Oh no, they're not the same. Definitely not the same. Which is bigger? The T. Because it's moving in a circle, there must be a force to the middle.
When they're moving.
When moving. So the T is bigger than the mg, and this is equal to F. Now, I have two choices. I can either say, and I can say MA equals T minus mg. So I have two choices for A. I can say A equals V squared over R, or I can say, A equals omega squared R, isn't it? Anyways, which formula for A should I use? The one with the V in it, or the one for the omega in it?
Omega.
Well, why would we choose V or why would we choose omega? So do we know the omega? No. Well, what's another formula for omega? Omega is 2 pi over T. Do we know the T? No. Okay. Right, well let's think about the V. Do we know the V? No, we don't. But actually the V is the one that will help us, because although we don't know the V here, we can know the kinetic energy here. And the reason we can know the kinetic energy here is because we can know the potential energy here. And I see that's the trick. That's the trick. So here this is mv squared over r equals T minus mg. Now you realize you nearly have the kinetic energy. What do I need here to make this kinetic energy? What's missing? Aha. So what would be a simple trick to fix this? I shall multiply both sides by a half. Now what has this become? kinetic energy over the radius equals T minus mg over 2. Wonderful. So now I can bring the 2 up here, and I can get 2 times the kinetic energy over the radius plus mg. That's equal to my tension. Now, do I know the kinetic energy? No. But the kinetic energy here will be the same as the potential energy here. So in the end, you can get this formula. Tension would equal twice the potential energy, which is mgh, over or plus mg. Now something nice cancels here. If you think about it, this h, which is this, is the same length as this, which is the radius, because it's moving in the circle. You can actually cancel the h with the or. 2mg plus mg, 3mg. So you take your m and you multiply it by the g and the 3. Now I feel like I made a mistake, because I feel like maybe the or should matter. But if I think about it, does the or really matter? Like, for example, if the or was bigger, then it would be going faster down here. Would it? Yeah, it would, because it would have more energy. So I feel like maybe I made a mistake. Maybe I've lost an or here, or maybe it doesn't matter. You have the answers on the marking scheme. We can check if it's right. What is 3 times 2.65 times 9.81, please? Can you type that in, please? What's it to 3 significant figures?
77.9895.
So it's 78.0 then, yeah. 78.0 newtons.
How we know if like maybe the height within the...
Yeah, how do we know it's like this and not... In the question they said, I think they used the word horizontal. They said
the height, like, I mean, is it the height there or the height from the ball to like somewhere down the floor?
Oh, yeah. In fact, it will not affect the answer. So even if the ground was actually down here, it actually doesn't affect the answer. However, by placing the ground at this level, it was convenient because I could make the or and the h the same. But you are free to set the ground at any level. It's like you're free to set the origin anywhere.
So if we set the h to like somewhere below, then why wouldn't it affect the velocity?
If the h is here,
Yeah.
why won't it affect the velocity in real life or in the calculation?
In the calculation, like mgh equals to half mv squared.
Yeah. So this h will now be different to this or. So you also have a second disadvantage. You can't say KE equals PE, because at the end it has now kinetic and potential. So because of those two changes, it will cancel and be the same as this. All right. Do we have the answers handy, or do I have to open them? 78 is the answer? Wonderful. Okay. Now I'm very curious to know if this is the way they did it in the marking scheme. Did they use kinetic energy?
Yes.
They did use kinetic energy. Okay. Right. We can take turns. So someone else next. Yeah, which one?
Omega.
Guys, can you focus, please? Yes?
Can we use omega?
What formula would you use for omega? Like, how did you get the omega?
2 pi over t.
And how did you get the t?
2 pi square L over g.
The pendulum formula.
Yeah.
This will provide a close answer, but I think because the angle is so great at the beginning, we aren't justified in using this formula. Now, I would like to know how wrong it is. So when you use that formula, what did you get for tension?
52.6.
Yeah, that's quite different. the idea behind the pendulum formula is only when the angle is small can you use it. So by small it's like 10 degrees, not 90. Yeah. Good idea though, good idea, but doesn't work here sadly.
This question is pendulum, not pendulum question.
No, pendulum's only small angles.
Then what's the subject? What's the pendulum?
Pendulum, but with big angles. What lesson is it from? Circular motion lesson.
Then what's the MA equal MB square?
Circular motion formula from the circular motion lesson. What's next now? Someone else, please. What page?
31.
Page.
31.
Yeah.
Version 486.
What lesson is this?
11.
Can I see that, please? Thank you. Page 31, version 486. Two cells, each of 1.5 volts, have internal resistance of 0.1 and 0.18. What is their combined internal resistance when they are connected in parallel? Okay, so part A1, they're in parallel. So here's one here. This is a 1.5 and a 0.1. 1.5 volts, 0.1 ohms. And this one here, that is a 1.5 volts, and that is a 0.18 ohms. And the question is, what is their combined internal resistance here? So isn't it just 1 over... Oh, it's the second part. Okay. Can you just give me the answer for the first part?
0.064.
0.064 ohms. Okay. Part 2. What determine the terminal potential difference when the parallel combination is connected across a 4 ohm resistor? So what you do now is you connect this across to a 4. So let me just redraw this. Yes, my spider senses are telling me something is peculiar here. Okay. And this is a 4. 4, 0.18, 0.1, and these are both 1.5. And we're looking for the voltage here, which is actually the same thing as the voltage here. Now, because we know the resistance here, if we knew the current, we would be finished, because we could just say VIR, V equals IR. So I wonder if this will be a little bit easier if I try to get the current, if I could use my buddy Kirchhoff. But I feel like I'm doing this the stupid way because there's only 2 marks. So, should I be brave? Should I be brave? This is my dilemma. Okay, let me explain my dilemma. If I use Kirchhoff, it's longer, but I know I definitely will get the right answer. But I have another idea which I think they want me to do, but it's risky. What should I do?
First,
the risk I get the wrong answer, which is, disaster. Disaster. Okay, we'll take the risky approach. See what happens. So, because they asked me to work out the combined resistance, it makes me feel like they want to imagine it now as just one single, like one battery with 2 cells inside of it. But what would be the voltage inside this if you put a 1.5 and a 1.5 together in parallel? Would it be 1.5 or would it be 3?
1.5.
I think it might be 1.5 because they're in parallel, so it should be the same. And we've already worked out what the resistance is in parallel. What is it? 0.064. And this is connected to a 4. Yeah. So, but you see, that feels wrong because the voltage here will be the same as the voltage here. Oh, but the voltage isn't 1.5 because that's the resistor. Question?
They use all these numbers, but why 1.5 instead of 2?
Because the two cells are parallel, so they have to be the same voltage. And when the total is still the same.
But what if they like use 1.5 volt and another 3 volt? Well then.
Yeah, now it starts getting whoa crazy. I think then you must use Kirchhoff to figure out the total voltage, because remember when we did the lesson on simple circuits, and I said at the very end, how does voltage combine when it's in parallel? And I put in brackets, it's complicated, we'll do it later. It's Kirchhoff. Now, we don't need Kirchhoff here because they're both 1.5. That's good because when they're in parallel, the total should be the same. Now, if you put a small battery with a big battery in parallel, I think you should still get the same voltage, so one of them must maybe lose voltage. You know?
You know how much they use?
We're using Kirchhoff to calculate it. I'll do it both ways. We'll see what happens. Let's just try it this way. So, here, what can I say? Oh yeah, I should get the total resistance. So I can make this now 1.5 volts and this a 4.064 if I combine the two together. So using VIR, what is, let me just get the I, because I really want to know what the I is. What's V over R? V, wait. Yeah, because it's in, or is, no, it's in parallel. Oh, this is getting very risky. I don't like it anymore.
How is it in parallel?
Yeah. There's a resistor here and a resistor down here. They're in parallel, not series.
What?
I know! This is what I thought. This blew my mind last year because I was doing this question with a student and I was convinced that when they're like this, it's in series because it's in a loop. So it's like they're lined up. But then when I looked it up, it's actually considered to be in parallel.
And the marking scheme is just plus. They just add them back.
Oh, mind blown. Right, this is too risky. I'm going back to Kirchhoff. Kirchhoff, we know him, we love him, he'll help us. Yeah. So what I'm doing here is, I'll call this one I1, and this one I2, and this one I3. Don't roll your eyes, it's not going to be that bad. Okay, so let's make my junction law here. What can I say?
I1 plus I2 minus I3.
Yeah, I1 plus I2 minus I3 equals 0. I can make a loop. Which loop should I make? Well, I really care about this one, so I should definitely include this. I should make two loops. I'll make one starting up here and one starting up here. So on the top, I get 1.5 minus 0.1 I1 minus 4 I3 equals 0. And then the other one I get 1.5 minus 0.18 I2 minus 4 I3 equals 0. Okay, what's the only thing in common that I can cancel?
I3.
Yeah, let me just rewrite these neater. I1 plus I2 minus I3 equals 0. 0.I1 plus 4I3 equals 1.5. 0.18 I2 plus 4I3 equals 1.5. Right, I'll need my calculator. I should multiply the first one by 4, shouldn't I? And then what I can do is I can minus these. So if I minus the top two, 3.9 I1.
Why minus?
Thank you, my friend. 4.1 I1 plus 4 I2 equals 1.5. And here I should minus.
Yeah.
0.
No. And first equation and third equation. Easy.
The first one and the third one?
Yeah.
Ah, no, I want to do it this way. It makes me happy. Minus these. So 0.08 I2 equals 0.
No, just I1 and I2.
Oh, sorry. Yeah. Then I can solve these. So, yeah. Sorry, Kirchhoff. I thought she could help me, but this is way too much marks for 2 marks.
Why is it 1.5?
Why is what 1.5?
The answer. They read the electromotive force is 1.5.
Yeah.
Why?
Isn't it here?
Yeah, but isn't it 3?
Oh, we're still talking about
Yeah.
3, but they're in parallel. The 2 batteries are in two cells are in parallel, so it should be the same voltage, and the total will be the same.
That's why.
When are they in parallel?
What is the question, actually? I've forgotten now what the question is.
Terminal first.
Is the answer in the book 1.5 in the marking scheme?
1.5?
1.48. I don't like this question. Alright, one more time. We put the 2 of them together. And we have the 2 resistors together. So this has an EMF of 1.5 volts and an internal resistance, what was it, 0.064 ohms. And this is connected to a 4 ohm resistor. And we want to know what is the voltage across the terminals. So, what would be the absolute easiest, laziest way to do this for 2 marks? That formula I gave you in class, E equals V I or plus or, is it? This one?
Yeah, that's a lucky thing.
But we don't know the I.
We are trying to find the I. And then after that they use like V equal I.
Alright, so we first find the I. Ah, yeah, okay, so we can say 1.5 equals I. So this answers your question. We're not adding the resistors together because it's not like a series or parallel. We're using the formula here, and we got this formula from Kirchhoff's loop rule. So the origin for adding the resistors together is from Kirchhoff's loop rule, not because we think they're in series or parallel. Okay, well I'm happy with that now. And this can give me the I. Okay, so what's the I here, please?
0.3691
amps. And then once we have the I, then we can have the V, because we can say V equals I or.
Oh my god.
Yeah, well, now it's easy.
But still don't get why is it 1.5?
We're still on this.
Yes.
What? Tell me your logic. Why do you think it should be 3?
Because there's 2 cells.
Yeah, but they're not like this. They're like this.
But then what's another cell for then?
To keep the first one company. I don't know. Whoever made this circuit put the cells in parallel.
So if exam they give the question like 1 3 volt and another is 1.5 volt, then what's the electromotive?
Oh, in that case, you have no choice. You have to use Kirchhoff. There's no way of knowing easily how these two combine in parallel. At least here they have the same EMF. When they're in parallel, the total will be the same, because in parallel they should be the same. But if you put a 2 volt with a 3 volt in parallel, you have a problem, because they should both be the same, and they will both be the same. So it means somebody loses voltage. Maybe the answer will be 2.5 for both of them.
And then when divide
No, I'm just saying, or it could be 2.6, because it will also depend on the ratio of their internal resistors as well. The only way to know is by using Kirchhoff. That's for that case. But because this is only 2 marks, then I wanted to use Kirchhoff, but it made it much too long to do. But do you know what? Do I still have my equations? I'm going to type these into my calculator and see if I get the same answer. Alright.
This is really hard.
Yeah, but we're talking about it too much because it's interesting. Mode 52. 1 minus 1. Where's the other? Okay, 0. 0.1, 0, 4, 1.5.
No, that's wrong.
Huh? 0, 0.1, 0, 4, yeah, 1.5. That's what I said. 0, 0.18, 4, 1.5. Now, which current here should match the answer I just got? I1, 2, or 3? Okay, so we want I3 from Kirchhoff's way to be 0.36. Okay, here goes. Right. Don't want this answer. Don't want this answer. Yeah. Nice. So we have confirmed that the answer is right by using Kirchhoff's loop rules. So that was satisfying, that question. Painful but satisfying. Yeah. Okay. No, we'll take turns. So.
Wait, what's a lot
no,
more
don't ask me
marks?
about the 3 volts. Don't.
Wait, what's a lot more marks if you use in the question like give you 3 and 1.5 and then you need to use Kirchhoff's rule?
Oh yeah. A Kirchhoff question should be at least like 5 marks. At least. But it can be as much as 12 marks.
Then, if we solve this question with Kirchhoff's rule,
Still get 2 marks. Yeah. Okay, who's next now? Someone else now. Over to the window. Your turn now. You are by the window, believe it or not.
Page 7.
Page 7.
Version 2A.
One.
Which number?
Number 2 and 3.
One at a time. Which one first?
2.
Okay.
I got the answer for 2, but I was wondering if I could do it another way.
What's the question about? The answer is yes. Because I know what you're thinking. You're thinking, can I do the time from here to the top and then the top to the ground?
No.
No, it's not that one.
No,
Let's have a look. Right, what's your other way of doing it?
The total 1.83 seconds minus the time it takes from the hand
to the top, yeah.
And the top to the hand.
Yeah.
And then minus, and then I'll get the time to go from below the hand to the ground.
Yeah, that's fine, but yeah, it sounds... You know how in the last question I was thinking about doing Kirchhoff, and then in the middle I had to face reality and said, no, this isn't the way, it's too long. I think it's the same thing for this one. Your way, although it works...
I was curious about the U and the acceleration that's used in the equation? Because I saw in the marking scheme the U is negative and the A is positive.
I don't like that they did that. You're allowed to do that.
Oh.
It's your decision on which direction is positive.
Uh,
So I don't like that they did that, but they did it, so it's fine. So what question do you want me to do on the board then? I think they got loads of questions. We'll get back to you, don't worry. Uh-oh, time's running out.
Page 18.
Okay, page 18 now.
Version 1, question A3.
18.
What topic is this?
Material, specific heat capacity.
Capacitor 1.
Specific heat.
Specific heat. Right. Thank you. A3. A brass weight of mass half a kilogram at temperature of 100 is lowered into a copper can of mass that containing that ice and that much water. My goodness. Assuming no heat loss, determine the final... alright, fine. Okay. So, you've got your copper can. You've got your brass weight. And you've got your water. And I want, of course, to have red because it's hot. Come on. Right, there you go. Who is gaining and who is losing? So, this brass fella here, he's going to definitely lose energy because he's going in at 100. Everything else will gain energy. So, at the beginning, this starts off at 100, but it will decrease to X. What is the container at? It's at... what is it at?
0.
Oh, it's because it's... Yeah. Oh, is there ice in here as well?
Yeah.
Oh, for goodness sake. Okay, ice in here as well. So this ice is at 0 and it will warm up to X. And this has to be at 0 as well because they're all in thermal equilibrium. And this also will warm up to X.
And water.
And the water. Hi. Is at 0 and it also warms up to X. Right. Here, you can be my assistant. Thank you. So, the energy lost by the brass, that will be MC delta T. Okay, what's the mass of the brass, please?
0.5.
0.5. And the specific heat capacity?
370.
Okay. Kilo or no? Just 370?
Yes, sir.
Okay. And the temperature change is it goes from 100 to X. And that has to equal the energy gained by the copper, which is M. What's the mass of the copper cup?
0.1, no, 0.35.
Okay. And the heat capacity of the copper?
385.
Okay. And it increases from 0 to X, so that's X.
Yeah.
And then the water, how much water is there? 0.25, is it?
Yeah.
And then it's 4181?
4180.
80. And that also goes from 0 to X. And finally, the ice. Now, the ice melts. So what's the mass of the ice?
0.1.
0.1 and the latent
334.
334 kilo.
No.
Yeah, must be. Can't just be 334.
Oh, kilo. Yeah.
Kilo?
Yeah.
Or not joules per kg.
Yeah.
What? Ho ho! I think they made a mistake. That's way too small.
Yeah. What?
Oh wait, yeah, that's way too small. I thought the latent heat of ice was 334 kilojoules, like 334,000. What did I give you in the lesson?
334, maybe 2.
I mean it's the same. This is 334 joules, and what I gave you is 334 kilojoules.
Yeah.
I did?
Answer is reasonable.
No, 334 is too small.
But they wrote it down here, so we have to...
Well, if this was a real life exam situation, if you use this number, I'd still give you full mark. But maybe some students realise there's maybe a typing mistake and it should have said kilo. It's true. If you Google specific latent heat of ice. Oh wait, no. Yes, Google latent heat of ice. You'll get 334 kilo. I'm sure of it. I'm willing to bet all the money in my wallet, which is actually quite a lot right now today. Huh?
24 joules. That's cute.
Per gram. Per what? Per gram. Yeah, per gram, which is 334,000 per kilogram.
Yeah.
That's a mistake. Okay. Now, what happens after the ice melts? It becomes water and it heats up as well. So, plus, I ran out of space here, plus,
No, do you need X?
oh, no, not here, because this is just to melt. And now it will increase, so, I'll squeeze it in. Plus, M,
0.1.
4180x, 0.1 there.
Yeah.
Oh no, my students are interfering with this again. You must be emitting some kind of interference signal.
The mass of water plus the...
Yeah, you can just add it. Yeah. Come on, dude. Come on, don't be a jerk. This question is painful because it's just a big equation to solve. Now, can we do any work to simplify this? I can add this onto this.
And then...
And I can also add it onto this. So I can put those three together. So I can also, okay, 0.5370, 100 minus x equals 0.35 times 385 plus 0.25 times 4180 plus 0.1 times 4180 x plus 33400. I got it.
Oh.
I got it. I know somebody has that remote that turns all TVs off.
Answer is 13.1.
What are you looking for?
This answer.
Anyways, do you need me to check the answer or do you just need me to continue? Because right now this is just boring algebra. Just rearrange it and get the x.
The answer.
You think the answer's wrong?
No. My answer is wrong.
Okay. But did you write this equation down?
Yeah.
You're not convincing me with a yeah like that.
So you what?
17.1.
Can somebody oh no, I did it myself. 0.35 times 385 plus 0.25 times 4181 plus 0.1 times 4180. So that's 1597.5. 0.75 x plus 33400, and then this one here 0.5 times 370 times 100, 18,500 minus, too lazy to do this in my head, minus 185x equals that. Yeah. Right, let's get the x now. So if I bring that over, and that's a problem because now my x is negative. My x shouldn't be negative, it should be positive. So which number is wrong? This number here is right. Hey.
But then the question says 334. Should we use the 334 or 334?
If this was an exam, you should use the 334. Wait, but did the marking scheme use 334?
Yeah.
Ah, interesting.
Why?
So they used the wrong number in the marking scheme. But why is my x negative? What did I do wrong? 33400. Don't know. I just don't know. I can't.
334,000 times. I thought you used 334 here.
Yeah, well, it was 334,000 times 0.1. So I just knocked off one of the O's.
Yeah, but then the question uses the answer uses 334.
Yeah, that's wrong. That's definitely wrong. The number, the latent heat of ice is 334,000. That's actually wrong.
I think that is wrong.
No, but I want to know why my x is negative. It means I made a mistake because my x should be positive. Yeah, possibly. It's possible that the ice doesn't. Huh? Yes.
So where is that 3 O's?
This?
Yeah.
Oh, I thought I'd made this clear. That's a mistake in the question. The latent heat of ice is not 334. It's 334,000.
But if they said the question using 334.
Yeah, you're right. Then that will fix my problem. So perhaps when they did the question, the reason I'm getting no answer here is because if I use the real number, I get no answer. So if I get rid of the extra zeros here, that does fix my x and make it positive. Now it's the wrong x because it's the wrong number that they use, but it'll match their marking scheme. Their question is wrong. There's the wrong number here. If I use the right number, I can't get an answer. If I use that 334, I think I can get an answer. Let me see. So let's just do 334 times 0.1. So I should, instead of having 33400, I should have 33.4. Okay? And if I take that over to the left, I have 18500 minus 33.4 divided by 185 plus 1597.75. 10 point.
Yeah.
Yeah.
This minus.
10.4.
I got this as well, but then the answer is 13.1.
Yeah, well, just to be clear, they've already made one mistake in this question, so I'd be willing to believe that a second mistake was made, because perhaps whoever wrote this question did it at midnight, because the exam was due the next morning, you know?
Yeah.
You got the same answer that I got using the wrong number that they provided. That's good enough for me. We can consider this one solved. Right, so who am I on to now next? Up the front then, or anybody else?
Oh, okay.
I have
Go on. Page
number 12 for John day before. Page 7.
Right, let's see. Got my pocket. This one? Nice. That's nice. Who's calling me? Who's this person? I don't want to talk to you. Oh, so much spam. Right. A copper wire of length 1.6. Okay, so there's the picture. There's everything. Right, can you all see the picture there? On the book? On the top on page 12? How can I get the stress in the wire? Or what's the definition of stress?
Stress? Force
Yeah.
over area.
Stress
Force over area.
is force over area. Now, I can't quite see in the picture, but the wire is then connected to another wire. Is it all one wire?
Yeah, this is one. This, and this.
And how long is this piece?
We don't know.
We don't know.
Yeah.
So it's a small length of not an important number. Can you look at the picture? Do you see in the picture they do this? But they tell you the wire is 1.6. Huh? Yeah, well, they tell you the wire is 1.6. How long is this side, do they tell you? And this side? So how long is this side? Well, it has to be 0. The purpose of that little... Well, actually, I wonder if anybody knows. What was the purpose of adding this in if we don't consider it has really any length, or the length is not important? What do you think the purpose in the picture was to add that in?
Clear indication.
Yeah?
For the current movement.
Not quite that. Not quite that. Huh? Yeah, but...
So that you can find...
Say again, yeah? Repeat.
Force over area.
To show the two things.
No, not quite. Alright.
Boom. Right?
No.
Boom.
Oh wait, boom?
Yeah.
Oh yeah.
Yeah.
No. The reason for this, I think, is if they didn't do that, consider what you would have. You would have this. Now, in the stress, you need to know the area. Yeah, there's a bit of confusion then. What's the area? Because is it going to be like 2 circles?
No.
But I believe by putting this little string here, they're trying to make it clear to you that you should only imagine the connection as 1 circle. I think that's the only purpose of this.
How do you know?
How do I know? Well, what other reason could there be? I mean, it has no length. You know?
Just to bend the wire and pull it down.
Yeah, but, you know, if you had is it 1 wire or 2? 1. So if you had 1 wire, you don't need to do anything. You can just hook something onto it and it will go down into a V shape. So why do we have to have the little string underneath it?
The hook. It's the hook.
That's the hook. That doesn't look like a hook. This is what a hook is. That's a hook. That's a string. No, you disagree? You think it's a hook?
No, it acts as a hook.
Should
It's
be.
not a hook, but it acts.
Yeah, but it says it's hung from the center of the wire. It doesn't say it's hooked onto the center of the wire. No.
The string has to be tied to the wire.
But they never mention anything about the string on the block. They only talk about the 1.6 meter string, right?
Yeah.
You need to trust me on this one. I believe I'm right here. Okay, anyway, like I said, the only purpose, I believe, of that string in the picture is to let the student know we should only consider 1 circle. Okay, so let's see what happens. What is the force? The force is the weight. What is the weight? That is mg. What is the m? 3. Now the area is pi r squared. What's the radius here?
0.0.
0.0.
0.4 millimeters.
It's 4 millimeters. No, 0.4 millimeters.
0.4.
Yeah, it's 0.4 millimeters. Is that the thickness or the radius?
The radius.
That's the radius, not the diameter.
Diameter.
No.
No.
Okay, so that's fine. So what do we get here?
No, you have scale.
Thank you. What do we get? Yeah, what do we get here? Can you type that in, please?
Okay. Oh.
Do you have an answer?
5854153.
58541
541 534.
534. I can call you on this anytime? It sounded like you were saying a phone number. No, you don't have to. You don't have to make it pervy, please. Okay. I wasn't being pervy, and then you were. Not acceptable.
Is that true?
It's not true. Right. What's your phone number then? Go ahead.
58.
Yeah.
54.
Yeah.
9164.
I'm not calling this number.
5850000.
5850000. That's my number. Okay. Call it any time. Right. What's the unit for stress?
Stress?
Yeah. Pascal. Okay. Right. Huh? Newtons per meter squared also. What's the second part here? What's the
Strain.
Now, I think for strain we should use the formula Young's modulus equals stress over strain.
We know that. Okay.
What? This is wrong, as in, you're not going to tell me, you're not going to tell me to use the 2 and the exact. What's the answer? Should it be?
6 point.
Now, is it wrong because someone mistyped this, or because
They use like f cos theta. They find the angle.
the angle?
They give 0.7.
So in the marking scheme, they don't consider the rope. Because there should be no angle if you look at the picture. If you look at the picture, it's going straight on the connection.
There's the 2 thingies.
Yeah, no. Yeah. Right, so let's start this again. Guys, the picture is not helpful. They should not have drawn the straight line. They should have drawn it like this. That's what it's like. It's not the same thing. It's not the same thing.
Cos theta equal to the.
No, but if I draw this or if I draw this, these are two different things.
Why?
If that.
Because here the force is acting in the direction of the string. But here the force is acting not in the direction of the string.
Also, we are not calculating the force of the string. So the tension of the string.
Yeah, but... Okay. This and this, the moral of the story is these are not the same picture. Okay. I think it was unfair to give you this picture because I thought the reason they were giving you this was to actually make it easier for you because you just have one vertical string and no angles or anything strange like that. In fact, they put this in for some reason I don't know now. Maybe to confuse you. Maybe to be a troll. I don't know.
It's hard.
I know. So I need to look at it like this. Okay? This changes things a little bit because now the tension is no longer this way. What way is the tension? Yeah, the tension is, yes it is, thank you. T here and T here. So this one here is T cos theta and this one here is T sine and this one here is T cos. So this one should equal that. Of course it does, because T cos equals T cos. But what we can say is the 2 on the top, 2T sine theta, what should that equal? mg. So now I can get the T is mg over 2 sine theta. Well, we have to draw now. So we know this side is 0.8. What else do we know? Do we have any other numbers? This is 0.8. What's 0.7? The top? Like here? Right, okay, and that's 90. And which angle do we want? We want this angle. Now, if that's 0.7, how big is this? 0.7. Okay, and that's 0.8. So what uses the hypotenuse and the adjacent cosine? So you can say cos theta equals 0.7 over 0.8. So theta is cos inverse 7 over 8. And then we can put that in. Goodness sake, what a question. What was the M tree? Yes.
Oh.
I'm doing it in one go. 30.395 newtons. Yeah. But of course that's now not the answer. We have to look at the stress. The stress is the force over the area. Now, big question is, what is the force and what is the area?
Force is that.
Yeah.
2.
And the area is 1 or 2 circles. Give me an answer. Which one? 1 or 2?
2.
Okay. So you're saying one of these and 2 circles?
Yeah.
No. 2 of these and 1 circle? No. You can either say one of these and one of these, or
2 and 2.
2 and 2.
2 and 2.
Okay, this will give you the same answer, but if 2 and 2 makes you happier, we'll go with that. 2 tensions and 2 circles.
Yep.
This will make you happy?
No,
It makes sense. Okay, good. That's better than being happy. Yeah, no, that's true. That is better than being happy. So the stress is 30.395 times 2 over pi r squared times 2. Can you see why I said it didn't matter if it's 1 and 1 and 2 and 2? Because I can cancel the 2's anyways. Right, let's see what we get now. Divided by pi times that squared. Is this the answer? Great. Great. How many zeros? 1, 2, 3, 4, 5. 6 or 5 and 5 zeros. That's the stress. That's what they said in the marking scheme.
But this picture is right.
This picture is stupid.
Stupid.
Picture. It is disgraceful. What year is that from?
14 maybe. 13, 14.
13, 14?
Yeah, 13, 14.
They changed who writes the physics exam in 2016.
That's right there. It's not good, it's not good.
Yeah, well, don't worry. The person who wrote that exam is not writing this exam, so.
So you don't write the final?
No, not the final one. The exam this week I write. Yeah.
Oh, so this one would be good.
Different.
No error?
This semester one and
It'll be good with no errors.
Is there error?
Have you not been in my class? I'm human. I'm willing to make mistakes. That's part of being human, unfortunately. Yeah. Okay. Next part. What do they want for the next part?
Strain.
Strain.
Yeah.
So I think we said Young's modulus equals stress over strain. So what does strain equal? Young's modulus, isn't it, over stress?
Yeah.
Or do I have it upside down?
Stress over strain. Yeah, Young's modulus.
Oh, well, that's nice and easy now, because what's Young's modulus for this question?
1.217 by
Yep.
10 to the power of 11.
This 5.17 10 to the minus 4? Is that right?
Right?
Didn't she have the marking scheme open? 5.17 times 10 to the minus 4. Okay, what's next? Let me guess, the extension.
Yeah.
I knew it. Because What does stress equal? Extension over natural length.
Why stress? Not
Sorry, it's been a long week.
You're
It's
stressed.
only, yeah, and it's only, it's been a long week, okay? The extension is the length times the strain.
Yeah.
And what's the natural length?
We don't know.
1.6. Now we have to be careful here because do they want the extension, like how far it hangs? Like it's 1.6, but we're looking at this as like two strings, a 0.8 and a 0.8, a T and a T, a circle and a circle. So the question is, do we multiply by 0.8 or 1.6 here? Well, let's read carefully. Can you read exactly what they asked for? What did they say? Okay, so I think I should use the full length
Oh.
because they want the extension in the wire, not how much it hangs down. And anyways, that's better because I would then have to use cos and sine theta to work out the vertical distance it drops when the string becomes a bit longer. It is probably only like 2 marks, is it, or 1 mark? 2. So it should be short. So I should just multiply this by 1.8, and I get this. Oh, flip. I get this. 8.27 10 to the minus 4. Yeah? What do you mean it doesn't make sense? This whole question doesn't make sense.
Oh yeah, I know. But this is wire. I cross this.
Yeah.
And this like this, like this, like this, like this.
Yeah.
There is that.
Yeah.
Like this.
Yeah.
But this is natural. Like
Yeah. Oh, I understand now. I understand. Yeah, actually, that's kind of bad in that question because when they give you the 1.6, that's not the natural length. That's the length after it's extended because the weight is hanging on it. Good point. Good point. That's another mistake. Wookie just noticed a mistake in the question. The natural length, they use 1.6 and I use 1.6, but it's not 1.6 because the object's already there in the picture. Yeah. Anyways, we'll overlook that. We'll put that into the the DVD section. Bloopers. Yeah, exam blooper. Okay, what's next in that question, or is that it? Is that the end of the question?
Yeah.
Okay, apart from the first part, the rest of the question was straightforward. So, how many marks was for the first part of it? No, the first part of that question. 3 marks. They made you work that hard for 3 marks. All right. Whose question was that?
No, I want to.
Yeah, but whose was this one? That was yours. Okay, so anyone else? Over here now? Okay, what's your one next?
Page 16, question A6.
Which version? Just A6 on the page? No, it doesn't matter. It's just there's no other A6s on the page. Can I see it? Dude!
B.
Are you looking at page 16, A6? Just the B.
D.
Aha. So if I skip the D, can you give me the numbers I might need? You have them?
Yeah.
Okay. D. So what you have here is you have a lorry and it's speeding along here and then it collides into a car and then the two of them move off together. Now, you probably worked out the speed they move off at, correct?
Mm-hmm.
What did you get for that?
22 after the
collision, yeah.
22.2.
22.2 meters per second. And we know the total mass is 32,000 plus 2,600, that's 34,600 kilograms. What force is required to slow the two vehicles down, assuming that the resultant force has a constant magnitude until the two vehicles come to rest? In other words, they want to know how much force would have to be applied this way to stop this coming towards you. So let me just draw that again. We have a mass. It's traveling at a speed of 22.2 meters per second and a mass of 34,600, and we want to know what's the force that causes it to come to rest. Isn't that what they're asking for? Yeah. Now it doesn't seem like we have a lot of information, does it? Like, if we want to know the force, we need to know M and A. Do we know M? Yeah. Do we know A? No. Could we know A? Let's see. Do we know U? Yes. Do we know V? Yes. Do we know A? No, that's what we want. Do we know T?
No.
No. Do we know S?
Oh yeah, but no.
No, we don't know S. So can we know A?
Yeah.
No. We cannot.
Yeah.
So, did they leave something out, or is there something in the question I didn't see? A sneaky piece of information.
You to find the log.
Ah, no, they give us the S.
No, that's for the C. What? Yeah.
After the collision, the lorry and car moved off together a distance of 53. So we know the S. So if we know the U and the V and the S, can we know the A?
Yeah.
And if we know the A, can we know the F?
Yeah.
Yeah. So we're finished.
Then why do they?
Why what?
The marking scheme do a different way, which I don't understand.
What way did they do it? Well, hang on. Before you say, let me just see if I get the same answer as the marking scheme. So what formula can give me the A if I know the UVS?
2AS equals.
Yeah, V squared equals U squared plus 2AS. What's V squared though? Is 0. So A will be minus U squared over 2S. Okay, what's the U? 22.2. Squared over 2. What's the S, please? 53 exact? Yeah, and then that's a minus. And then we have to multiply by the mass, which is 34600. So minus 161,000 if I round it off. Kilonewtons. I think actually I should say plus because they probably asked for the magnitude of the force or how big the force is. So I don't. The minus was because of the direction, but yeah, magnitude of it. Okay.
So this force is to slow down the car and the lorry.
That's it. Stop it. Yeah.
What is this
It's truck. What way did they do it in the marking scheme then? That's so different. That confused you.
Like the question C, they asked us to determine the loss of kinetic energy. So I find the.
Oh, there is another way to do it. There's another way to do it. The other way you can do it is if you have something moving and it has a kinetic energy and you want to apply a force to stop it, then the work that you do will equal the kinetic energy here. Yeah. So if this is moving with a kinetic energy of 10 joules, I will need to do a work of 10 joules to stop it. Okay, but there's another formula for work. What's the formula for work? Force by distance. So if you already worked out the kinetic energy from an earlier part, you just have to divide that by the 53 and you have the force. Yeah?
Why do we use the final kinetic energy instead of the loss of kinetic energy?
Because the final kinetic energy is final after the collision. We're looking at the second stage. So this has a kinetic, this has a kinetic. They connect, they lose kinetic, and now they have a final kinetic. Yeah. But that's the beginning now of the second half, which is it coming to rest. So that final kinetic from the collision is actually what we start at in the second part. Yeah. So it's this number divided by 53.
Even the final kinetic divided by 53.
Is the quickest way to get the answer, yeah.
If I use the loss in kinetic, the
No.
I'll get
No.
For what? The answer
The answer is
is for...
is wrong.
No, I mean for like the...
For nothing.
Oh, really?
For nothing. Represents nothing. The loss in kinetic energy would perhaps represent heat or sound. That's all. Okay, what's next? Who asked me that? You asked me that. Right, who has a question next now? Yeah, come on, I'm running out of energy. There's only so many more questions you can get out of me, because you're picking hard ones.
Page 9, version 2, question A1.
Page 9, version 2, A1. Okay. Read it to me.
An object of mass 3.56
Yeah.
slides down a smooth, frictionless slope inclined at an angle of 25 degrees to the horizontal.
I like it already.
Okay.
Go on.
1. If the object starts from rest, determine the time taken for it to reach a speed of 18.5 meters per second.
Right. 18.5
Yeah.
meters per second.
The
Right.
question is Newton's 3 law?
Yeah. What way would I like to do it? I think I will do it this way.
I tried to use the triangle from the bottom.
Yeah. No, the triangle I think is what you need. If you look here, the gravity is pulling it down this way, right?
Yeah.
That's 3.5 G. However, we don't care about that direction. We want to know how much of it is going this way and how much of it's going this way. So we should resolve. If this angle is 25, then this angle is 25. So this one here is 3.5 sine 25. That's the force. Okay? If F equals ma, where's my G gone? There's a G in here. If F equals ma, then how can I get the A?
Sorry, the mass is actually 3.56.
Okay. 3.56
I'm done.
3.56 G sine 25 is the F equals M A, and I want the A going this way. So I should divide by 3.56, and so the A is G sine 25. Can you tell me what that is, please? Oh, 0.146. 4.146. Okay. And the V is 18.5 meters per second, and the U is 0. And what did they want? The T. Can you get the T?
Yeah.
Do you need me to get the T? No. Yeah.
Why the 3.56 G sine 25 is equal to MA, is that not the minus friction? So, there's no friction. No
Yeah.
friction, minus.
Yeah.
I see, okay.
Is that it?
Yeah.
Question finished?
Yeah.
Oh, thank you. Okay, what's next now? We don't have to take turns. I just wanted to be fair. I told you there's loads of questions.
For this question, if you want to find the distance, you can just take speed by time.
I'm shocked that you said that. Because that only works if the acceleration is 0. It's constant speed.
It's not.
No. Don't like I said earlier. We're all human. These things happen.
The speed is average.
You could use an average speed if you like. Yes.
did it with average.
Okay. Did it work?
One time. Yeah.
It worked? Yeah, so you can use an average speed. So if you want to use the distance speed time triangle, but we don't know the distance, do we? Did you work it out? Yeah, okay. So you worked out the distance.
And the next part is the distance. Determine the distance traveled.
Right, okay. Yeah, average works fine. So it would start at 0 and goes up to 18.5. So it's 18.5 divided by 2. But you realise that's actually you just using this formula, which is actually one of the 4 formulas. Yeah. Okay, next. No, she can go. She's going to have a hard one for me. Go on. What is it?
Page 17, version 4A1.
Page 17, version 4A1. What topic is this? It's not another mechanics, is it?
Yeah.
Okay, go on. Can I see the picture? What is it? Is it the picture one? Ah, yeah. Okay, go on, yeah.
For B,
Yeah.
why is the height is they give like sin 15 equal h over 5?
Because it is.
But then the 5 meter is like halfway on the slope. It's not totally.
The picture is not like, I get what you're saying. They're like ignoring the dimensions of the box and everything like that. We need to consider the box as if it was a point and the slope as if it was a line, and it starts from the bottom and goes to the top.
I didn't start from the bottom.
I know the picture is disgraceful. I know. That's all right. What's next?
V.
Yes, Mookie.
Page number 13.
Okay.
Page number...
Hold on. We're not there yet. Page 13.
Number 8.
Which?
Number 8.
Okay. Can I see it? Guys, come on. Are you looking at this one? Page 13, number 8. Okay. Yeah, okay. Just give me a sec, please. How much more of this do I have to put up with? Oh, not much more. That's good. Okay. No, thank you. Okay, so let me draw this here. We have our wall. We have our shop sign. And this is straight. And this is here. Okay. And then this is here. Right, and let's put in some forces. A uniform shop sign of mass 8.5 with 0.6. So here is 8.5 G. And because they said it's 0.6 wide, I know the distance from here to here is 0.3 meters. Okay, next. Hangs on a 1 meter long mast. So this is 1 meter long and its mass is 1.5. So here in the middle, this is 1.5 G. What's this distance from here to here? That's 0.5. So what's the distance from here to here? 0.2 meters. Okay. This distance here is 0.8 meters from here to here. And the question is, what's the tension in the wire, firstly? Okay, let's have a look here. The tension in the wire, I'll just draw it like this. Now there's actually a reaction force here. So in total there are 4 forces. Now that's important for me to say because we cannot use the 3-force theorem if there are 4 forces on it. So we have to do this the other way, which is looking at all the forces. So definitely should calculate the theta here. Can we know this theta? We can, because if I draw the triangle, this side is 0.8 and this side here is 1.
Okay.
So theta is tan inverse 0.8. What's that, please? 38.66 degrees. Okay. This component is T sine, and this one here is T cos. The T sine I care about because if I make this as a turning point, do I need to consider the OR? No. Clockwise or anti-clockwise? Are you guys sure? Here, this one is clockwise. This one here, clockwise. This one here, anti, and this one here. This one here.
Oh,
Nothing. Because.
Yeah.
Or rather, it passes through the turning point. So these two should add to make this one. Right, what is the force and what is the distance for the first one? Force 1.5 g. Distance 0.5 plus 8.5 g times 0.7 equals this last one here. What's the distance? 1. And the force is T sine theta. Can you get the T from this?
Yeah.
You can, yes?
Why aren't the down forces equal to T sine?
Oh, they are. You can make this equation too.
And
That actually would... why can't you do that? Because that seems like it should be quicker. You can say that this equals this and this, yeah?
plus R.
But we'd have to introduce another variable, which is the or. Or y and or x.
Also, we counted the up and down forces. Did we use the sign?
For which this one here?
Yeah.
I use this as the turning point to cancel all of these reaction forces because we don't need to consider any force that passes through the turning point. The same reason we don't consider this one because it'll pass through the turning point. So only this guy, and this guy we care about in the turning.
But why can't it work if we like do R sine theta is plus
No, it can work, but there are three problems. Number one, you don't know or y. Number two, you don't know or x, and number three, you don't know the angle here. I think that's a good enough reason not to consider this, if possible. Is this okay?
Yeah.
Can we know the T? Yes. Now, if we know the T, the next question is what is the or x and what is the or y? So if we know T, we know everything because what would or x equal? That would equal T cos theta. And we know theta? Yeah, it's 38. Okay. We know theta. Do we know T? Can we know or x? Yeah. Now how can I get or y? I could say or y plus T sine theta equals 10g. I add these two together. The two up forces equal the two down forces. So this up plus this up equals this down plus this down. Do I know 10g? Yep. Do I know this? Yep. Do I now know T? Yep. So can I know this? Yep. And that's kind of strange because you get 5 marks for finding or x and or y, even though that's kind of easier than the first part, which is getting the T, which is only 3 marks. I think is strange. So you get 3 marks for this, but 5 marks for this? Doesn't make sense to me.
If you get the first one wrong, you get all wrong.
No, because there's a chance that the error will carry to the... I won't penalise you in the second part.
Yeah?
It depends on who wrote the exam and if they're a jerk or not. Because what happened 3 years ago was I used to do this where if you make a mistake in the first part, I don't mark it wrong in the second part. And I did this for like 7 years.
But then the answer would be wrong.
Yeah, I know, but you did it right using the wrong number at the start, which isn't your fault because you lost marks in the last part anyways. So I used to do this for like 7, 8 years, and then 1 year they said, no, you can't be doing this. I'm like, but I did it for 8 years. I'm like, no. I'm like, okay. But that was the maths teacher. And the physics teacher never said this to me.
Yeah, because you are only
Well, the physics teacher is new at Manchester. I feel like he's more flexible with this type of stuff. So I could try to mark it as right, even though the error means it's wrong. But because I already took marks away from the previous answer, I should not punish you twice. But there's a possibility that at the end of the year when he looks at my exams he says, what? No, you can't do this. Tut, 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 tut.
So like if you got the first part wrong, the whole question is wrong, or only...
Well, like in this particular one, yeah, that will be the case because you need the tension to do part 2 and part 3.
We won't even take marks for the formula.
Oh yeah, you might get 1 mark for the formula and 1 mark for the formula, so you don't lose all the remaining marks, but you would lose most of them. But what I would prefer is to give you all the remaining marks, because you did everything right, it's just you had the wrong number at the very beginning because of part 1. But if I already took marks away in part 1, I shouldn't then punish you a second and third time, you know. In Manchester, they don't often agree with me. Maybe they don't like me. I don't know. But I do agree that it would be unfair to punish you 2 more times for a mistake made in the first part.
Like what's the maximum marks like they do? Like the first question you did it wrong. Like how many questions will...
You want to know,
one.
in your worst nightmare,
Yes.
how many marks could you lose if you made a mistake in the first part? In the section B, these are the long questions, but even the long questions are broken up into 2 halves. So in the worst case, if you had something like half the section B question lost, so that could be, the worst you could lose is maybe 6 marks.
What? But then like the Kirchhoff rules and thing is already 6 marks.
Yeah, and what did I just say? The worst you could lose is 6 marks.
No, but then only A1. No, it's A2 is worse. I thought the B1 would be worse.
I really don't know what you're saying.
No, like it's A1.
Are you asking me something or just complaining?
No, I would expect it to lose more marks. Is it possible to lose more marks?
Anything is possible.
Okay.
Anything is possible. You could lose lots of marks in section A, you could lose lots of marks in section B, and you could lose lots of marks in section A and section B. Okay. Any other questions I can help you with?
Question.
No time left.
No.
No time left. No time left. I'm tired.
You have 2 minutes.
We don't. We didn't take any break today.
Just now.
Okay, short question. Like,
Hang on. It's, you know, I have to tell you something. It's my wife's birthday today and I have not bought anything yet. So I need to get something before I get home. Okay? So I was hoping to use the 20 minutes between getting the train. Yeah, like I have to get a train. Okay? So I have about 20 minutes in the train station before my train arrives. I was hoping to use this time to buy something in the train station to bring home. Now, if I go home with no birthday present, what am I supposed to say? Oh, well, Wookie, you know, he had a question, and, you know, sorry, you know. Excuse me, I'm a man, okay? This is not how I think, alright? What's that? 20 minutes is plenty of time. Plenty of time. Don't underestimate my ability to shop at the last minute.
You can't get a shitty.
You are underestimating me. Don't underestimate me.
Good or not.
I've been doing this a while. I can do this.
You'd have to wrap them long.
No, I'll buy one of those gift bags and put it in the gift bag. Yeah. Actually, I already bought the card at lunchtime so I can fill it out on the train. No. It's nothing could possibly go wrong.